Everyone, welcome to this video, and in this video we're going to discuss about sets. Let's define now set. Set is a collection of a well-defined object. So the keyword there is well-defined. Some example. First one is set of silverware. As you can see on the image, silverware are the spoon, fork, knife, and plate. Another example is set of tires for a car. So technically there are a number of tires in each car or any vehicle. Another is set of encyclopedia. For all these, we could say that this is the manual search engine or Google. So that's it. Another is set of counting numbers. So when we have counting, we start with 1, go on to infinity. Let's have another concept about sets. So elements or member of a set. This or the object in the set is known as the element or member of a set. This example. So giving a set of first 5 counting numbers, we can say that A is equal to 1, 2, 3, 4, 5. So those are first 5 counting numbers. So 1 is an element of A, or we can denote it by this symbol. 1 is an element of A. As you can see, 1 is inside set A. Another example, 2 is an element of A. As you can see here, 2 is inside A. Another, 6 is not an element of A because 6 is not in on A. So therefore, 6 is not an element of A. Let's have them practice. What are the elements of set below? As you can see, we have B, A, B, C, D, and E. So the elements are A, B, C, D, and E. Let's talk about notation and description of sets. Example is set A is equal to A, E, I, O, U. The first one, how to write down a set, is known as the roster notation or listing method. Now, the roster is just similar to this one, where A is equal to open braces A, comma, E, comma, I, comma, O, comma, U, and then close braces. That's how you write it in a roster notation or listing method. Another way is known as the verbal description. The verbal description is the vowel in the English alphabet. As you can see, we can describe now the elements as a unifying descriptor, which is A, E, I, O, U, are the vowels in the English alphabet. Another is the set builder notation. Normally, they use this in an algebraic class. So, we known as A is equal to X such that X is the vowel in the English alphabet. We read that as X such that X. Let's have some practice. So, set of primary colors. We denote the set of primary color as C. So, if you were asked what is the roster notation, you can write it in this way. C is equal to open braces red, comma, blue, comma, yellow, close braces. Now, if you were asked now what is the set builder notation, we can say that C is equal to X such that X is the primary color. Let's go in another concept which is known as the null or empty set. When we say null or empty set, is the set with no elements. Let's have some example. First one, D is a set of Filipino that wins NBA championship. So there is no Filipino that wins an NBA championship as of now. So another, R is equal to a swimming pool in Jose Rizal University or in JRU. We don't have swimming pool yet in JRU. Another is A is equal to the symbol of null set, which is an open and closed braces. And another is K is equal to, this is a symbol of no elements. Another is E is equal to the eighth member of BTS, which is a K-pop artist. But there is no eighth member because there are only 7 members of BTS. Another concept is known as the cardinality of sets. When we call cardinality of set, it is the number of elements in a set. Have some example about cardinality of set. So here is a set. A is equal to red, blue, yellow. Now, we need to count now the number of elements inside set A. So 1, 2, 3. And we can denote that by n of A is equal to 3 because there are 3 elements inside set A. Let's have another example. The vowels in the English alphabet. So as a common knowledge, we can say that the vowels are A, E, I, O, U. So therefore, we can have that the n of B is equal to 5. C. So we have now 1, 2, 3 ellipses, 8, 9. So we can say that the number of cardinality of set C is 9 because it's from 1 to 9. Let's have another concept known as the finite and infinite sets. So when you talk about finite set has definite number of definite cardinality, while the infinite set has no definite cardinality. Technically, this is now infinite, so which mean would be an infinite symbol, and this has a certain number. So let's identify if the given set is finite or infinite. First one, set of English alphabet. It is finite because there are only 26 letters in an English alphabet. Another, A is equal to 1, 2, 3 ellipses. So this is an infinite because it's never ending. Next is set of president of the Philippines. As we could say, it is finite because there is a certain number of president. As of now, I believe there are 17 president. And last would be B is equal to Y such that Y is odd numbers. Should be numbers. So that is infinite because it starts with 1, 3, 5, 7, 9, and so on and so forth. Okay, let's have another concept when it comes to set known as an equal and equivalent sets. Now, first thing is that we call about equal sets. So equal sets are sets with same elements, while equivalent sets are sets with same cardinality. So let's have some example on the next slide. Let's analyze if it's an equal set or equivalent set. The symbols are here. So this is the symbol for equal, and this another one is similar. Let's have the given. A is equal to 1, 2, 3. Set B is 2, 1, 3. C is 4, 5, 6. And D is ABC. Now, let's analyze A and B. We can say A and B are equal set because what's inside set A is the same of what inside in set B. However, the order in set B is different from the order from set A. Another, let's analyze now set A and set C. Set A and set C, when you check the cardinality, there are 3 elements in each set. However, the elements inside are different. However, if they're only the same in the cardinality, we call them similar or equivalent. Next, B and D is also similar. On set B, we have 2, 1, 3, and set D is ABC. They have same cardinality, so therefore B is equivalent to set D. I hope you learned something about the fundamentals about sets. Thank you for watching this video and have a great day.